So hi guys, today I would be starting off with a playlist of TensorFlow basics. Uh, for basic significance, I would like to tell you that I am a certified TensorFlow developer and I am a second youngest developer certified by Google in field of TensorFlow all over Asia. So today in this playlist I would be telling about what would be the overview and a very basic introduction to TensorFlow and building a very basic model. So first of all, you all must be thinking that why should we use TensorFlow and not any other framework. So for that I will be taking you all to the Google Trends website where trends are compared with each other. So in this, I would be showing you comparing the three things that are Keras, TensorFlow and PyTorch. So if you are not familiar with any one of them even, then it's fine. So you can see that Keras is a software which is used by TensorFlow. It's a API which is used by TensorFlow for building models and compiling and all. PyTorch is and TensorFlow are two machine learning frameworks used by a good amount of multinational companies. So when I'm doing this in worldwide, you can see one thing that Keras and TensorFlow are both at their rising phase, and even PyTorch is at its rising phase. But the thing is, in recent time, you can see that even Keras, which is just an API used by TensorFlow, it's not a machine learning framework by its own, is being used by which is a subsidiary of TensorFlow. You can say like that. Is even giving a tough competition to PyTorch, and TensorFlow's graph is at higher pace than PyTorch. And if I show you of United States, you can see that if I do that, you can see then at that time TensorFlow and the PyTorch are at same phase. If I do of another big country which use I would do of India. At India you can see PyTorch is rarely used anywhere because even Keras is defeating PyTorch in that. Keras is just an API used by TensorFlow, not a self-sustained machine learning framework. TensorFlow is a machine learning framework, and Keras is itself defeating in the Google Trends graph PyTorch. So this is why you should learn TensorFlow and Keras these days because they are really awesome. And I would be showing you that which companies use TensorFlow. So giving you a brief introduction about TensorFlow, what is TensorFlow? So TensorFlow is an end-to-end machine learning framework, open source platform for machine learning. It has a comprehensive, flexible ecosystem of tools, libraries, and community resources that lets researcher puts the state of art in ML and developers easily build and deploy machine ML powered applications. So if you go on to the TensorFlow website, you can see that TensorFlow is can be used for, if you see learn here, basic core machine learning. You can even use it for web development. If you are building a website and you need artificial intelligence and machine learning things there, you can use TensorFlow there using JavaScript. For mobile and IoT also TensorFlow Lite is available. That is, I haven't worked with iOS, but I have worked with Android. So in Android you can connect your Kotlin application using Java APIs and Python APIs in TensorFlow Lite. And for even for production based models and deployment servers, TensorFlow extended can be used. So if I go down here, you can see the big companies which use TensorFlow. You can see big companies like Airbnb, which is one of the best company in terms of culture and coming to the strength of tourism and all. Coca-Cola, Google, DeepMind, Intel, Twitter, all these use TensorFlow. Even Airbus, you can see Bloomberg and eBay, Dropbox, Lenovo, and LinkedIn, PayPal, Snapchat, SAP Labs, Uber. All of them use TensorFlow because TensorFlow is a framework which is very at its rising phase, and you can see the videos here, the how TensorFlow is solving not only management and technical issues but also social issues, like helping doctors detect respiratory diseases using machine learning as TensorFlow as their framework. You can surf at their website and learn about TensorFlow, how things are changing. You can even be part of community, and the best part is it is open source. That means you can even contribute to them by going at their GitHub page and seeing the issues and pull request and make a pull request of your choice. Okay, so now coming to the what is Keras? So Keras is an API designed for human beings, not machines. So Keras follows the best practices for reductive cognitive load. So built on top of Keras 2.0, that is TensorFlow 2.0, Keras is an industry strength framework that can scale to large clusters of GPUs or an entire TPU pod. It's not only possible, it's easy. So you must be thinking what environment I am using. So if you have used Jupyter notebooks, Google Collaboratory is just a copy of that. You can think like that. Yeah, if you just need to go on Google, you need to search Google Colab, and you can see the Google Collaboratory is here. Yeah, then you would go here and create a new notebook. It's really simple. You just need to follow some basic tutorial and the guide they give at the beginning, and then in Colab it is just made for basic Python stuff. If you want to do IPNB, that is Magic Python, just like Jupyter Notebook. So here you can see the runtimes which are available. So they give you a runtime of GPU and TPU both. So as you must be knowing, GPU is much faster than TPU, and they provide it to you for free. Just imagine you are getting a full server of GPU for free, so you can run your models so fastly. If you do that on your laptop or PC, it would take a lot more time. And the main reason I would be using GPU is basically because when we are training models, we need efficiency, and GPU provides you that efficiency. And the reason for using the Colab notebooks is because I want to share the notebooks, and you would all even be able to run these notebooks at your own. And one more thing is that when you install some configurations like TensorFlow or Keras on your laptop or PC, you need to do a lot of configurations. So I don't want that to happen. I want things to go quite simple. So the prerequisite of this playlist and this video would be you must have some basic knowledge of Numpy and Python. That would be enough to get started. So I would just do connect here, and I have the as GPU, and it's getting connected. So it's connecting my notebook to a GPU. So what model we would be making is Celsius to Fahrenheit. We would be training our model telling that okay, these are the Celsius values, these are the Fahrenheit values. You need to learn how we are converting them without giving the formula. You must be thinking this is a boring or a very basic model, but yeah, that's how even I started. So I guess that's the best point to get started in TensorFlow. So the first thing we need to do is importing TensorFlow and NumPy, as we would be needing both of them in our module, in our means project. I wrote module by mistake. So now we need to declare the data of Celsius and Fahrenheit. We are declaring this as minus 40, 40, minus 10, 14, 0, 32. Just making the normal formula. We have been given Fahrenheit, and this is temperature, and this is the Celsius value. You must be knowing that when we are converting temperature in Fahrenheit to temperature in Celsius, we would be multiplying the value by 1.8, that is 9 by 5, and we would be adding 32 to it. So same thing we have done here. We have given np.array, that is it is reading from using the numpy module the values here which we have given it minus 40, and you can even extend these values. You can give it as many values as you want, and I would be running it here, and yeah, it has run. So now coming to the next part, we would be now training a model, which is the most important thing. You would be training your model, and then you would be making a model trained enough to predict on some other values. So you must be thinking what these all are written. This is all written. So I would be telling you now only. So you must be seeing I have declared a value LO equals to L0, that is TensorFlow tf.keras.layers.dense, and units equals to 1 and input shape equals to 1. Okay, so basically the tf.keras.dense basically implements the operation that is output of activation input and kernel, where activation is the element wise activation function passed as the activation argument. So what we are basically doing is, if you go to the link I have provided here in the notebook, you would be seeing that tensorflow.keras.dense is basically used for telling that how much you are providing to the dense layer, because TensorFlow works like a neural network. You would first be declaring it, and you would be telling how deep it is. So the input shape is 1, the units are 1. If you go down here, you would be seeing such examples that yeah, you can see the shape that is 16, 32. So the model is taking input of arrays of shape 16 and output arrays of shape 32. The first layer you don't need to specify, because we are just declaring a single layer. So you can see that here we are declared the units as 1 and input shape as also 1. So we would be giving it as input shape as 1, and we would be taking that also as 1. So then we would be declaring keras.sequential.lo. So basically this is just like, you can even search for that. When we are defining a model, we need the model to be in a sequential form. If you search about tf.keras.sequential, you would find out when we are declaring a model, we need to specify how it is going to be trained. So before that, I have declared it as this. So model would be basically, when we have decided, we have put up all the things in the first line. L0, we have given the data which we used here in Celsius and Fahrenheit in a tf.keras.length.dense way. Means we have given a data to L0. Now when we are declaring a model, we have container data here in a single line using the dense value. You can imagine it like that. You have put your data in a single format, and you have given that, okay, we are giving the input shape as this, and we would expecting the output shape as this. And now you have declared your model as equals to tf.keras.sequential. So the model is declared on the basis of the data that you have provided to it. So if you want, you can even see that, okay, option in the first layer you can receive the sequentially groups a linear stack of layers into a tf.keras model. Means you are declaring a model using this. Now model.compile, loss equals to mean squared value, and optimizer is equals to tf.keras optimizer atom. Okay, now coming to the model.compile. Compile, you must have got an idea that we are compiling the model now. So the model.compile method configures the model for training. So you must have seen the loss function which is given, and an optimizer. So what is loss function basically? If you go to the website, the purpose of loss function is to compute the quantity that a model should seek to minimize during training. That means you are seeing that how much quantity we should give the model to minimize the training. So there are a lot of loss functions available. So I would just read out the definition for you. Yeah, is to compute the quantity that a model should seek out to minimize during training. So we are giving the loss function to the model to make sure that that the quantity that we are giving to it should get minimized during the training. Yeah. So there are a lot of loss functions. You can see by cross entropy. Basically, when you study each of them in deep, you would realize that they all have their own significance. That is, binary cross entropy is used for image classification when you are giving two classes. Just like that, for regression, you must have got. I hope you must have got a basic idea of regression. Because these things are basic part of machine learning, the building base. So when you are giving mean squared value, you can, if you go here, because I have used the mean squared error. So you can see when we are giving the basic computation of mean of squares of between labels and prediction, we would be using this. You can see here, when we are yeah, we have given two values, that is both the square both the values are using 1 as input. Then at that time we would be using this to compute the mean of squares of between labels and predictions. Now coming to optimizers, what is optimizers? So optimizers are the expanded classes which include the method to train your machine learning or deep learning model. So right optimizers are necessary for your model as they improve training speed and performances. So if you go to the optimizer, that is Keras website, you will get is an argument of the two argument required for compiling a Keras model. So these two arguments are must. Without them you can't do that. You need to declare a loss function and an optimizer. For now I have declared my optimizer as Adam. If you need to learn more about optimizers, you can go scroll down here and you would get a lot of optimizers. They are basically these six. I have used Adam. You can study about Adam here. The Adam class it implements the Adam algorithm. I won't be going in deep. If you want to study about Adam algorithm, you can go here. Even right now, when I am we have become a TensorFlow certified developer, without documentation, learning is not possible. I keep looking at documentation, learning, and seeing which algorithm is best for my model to get fit. For now, I would be using Adam. So I have declared the learning rate. The so I have declared the it as Adam and the learning rate as 0.1. Yeah. So now coming to the next part, that is model dot. I would be declaring a variable history, and I would be putting it as model dot fit. So inside that I would be putting the two values that I need my model to take into consideration, that is Celsius and Fahrenheit, and I would be putting epochs as 500 and verbose as false. Okay, so for now, what is basically model.fit? So model.fit trains the model for a fixed number of epochs. You must have got an idea. It is the basic function which is used for training your model. And what is epochs? How many times you want your model to run on that training process. For now, I have put it as 500. You can even put it as 200, 100, 300, as much as you want, depending on the size of your data. Just imagine if you have used 3 GB or 4 GB of data, and then you are putting epochs as 600. Just imagine how long it would take. But in production deployment at cloud servers, we use GPU. So obviously we want the best for customers and a machine learning model, so we do that. It is time consuming, but that's the only solution. So here you can see compile method. Yeah, you can see the optimizer and all given here. So for now, basically epochs is how many times you would like that to happen. I have even given that definition here. Then an epoch is an iteration over the entire x and y data provided. That model would be going again and again on x y like this. And note that in conjugation with the initial epochs, epochs is used to be understood as final epoch. The model is not trained for a number of iterations given by epochs, but merely by the until the epoch of each index is reached. So you can imagine it like that. It is going again and again on that this Celsius dot Q and then Fahrenheit dot, like it is going and again and again on like this. And once it is done with that, it would stop, and it would show you the result. Okay, then comes the verbose. So basically there are a lot of functions in model.fit, but this is a very basic model, the first model that you are building. Hence I am showing you the only basic functions that I used. Okay, coming to verbose. So what is verbose? It is a by setting verbose 0 1 2, it takes only three values. When you it is basically not essential, it is not a very big term, but yeah, I like that, so I am showing you that. So when you would put verbose equals to 0, it would be training on its own, and it would be showing you anything, that okay, your model is getting trained, I won't show you anything. But if you put verbose equals to 1, it would be showing you a line like this. It's just a graphical representation that okay, your progress is in progress, your progress is like going like this. It is a animated progress bar. And when you put progress equals to 2, it would just mention the number of epochs like this, like 1 by 10 has done, but 2 by 10 are done. Okay, so I would be running the model now. So yeah, it is on a on a state where it is get, yeah, as you can see, it is going like that. So it's going very fast. The only reason is because the data is small. Just see how much values we have given. We have only given 1 2 3 4 5 6 7 8 values. On the basis of 8 values, don't you think it's really fast for a machine to get learned and trained? But when you're giving a lot of values, it gets hard for it, definitely. And even these values are only 1D values, means just think these are basically numbers. Machine learning models are used for basically image classification and object detection, not this type of stuff. So yeah, so we have trained our model, making it learn that what is the difference between Celsius and Fahrenheit, and how we are converting one to another. Now I would be predicting it. So what is model.predict? It's obvious. It's predicting the results on the basis of which how it is trained. So I would be putting 100 as my value, and we would be seeing that what is the value of 100 when we are predicting the model on the basis of trained data. So I'm putting, yeah, it's giving 213. Okay, Now I would be converting Celsius to Fahrenheit. Yeah, and I would be putting this as, yeah, it's showing 212, it's 213. Just it's a difference of 1 degree. So because if we go give more values to a model, it gets more trained on. If you get less, more. But according to me, this is really close, because it's like 99.5% close to the value we actually needed. So it's a nice prediction, because you can't be always 100% correct. Even if you are training on an image classification, you are detecting images between dogs and cats, you can't be 100% correct. It can be 98%, 97%, because it's a machine, not a human. So yeah, we have got a value of 99.95% accurate. So I guess it's really nice. So this was it, and in the future I would be coming up with some awesome videos of image classification and going deep into TensorFlow. I would also be diving in TensorFlow Lite after we are done with TensorFlow, then production and deployment. And this is how Keras API and TensorFlow are used together. And if you want to contribute, you can go to the GitHub page, and I would be linking the link to this TensorFlow basic collaboratory in the description. You can check it out and even run the model from yourself. And hope you have enjoyed, like the video. Thank you and have a nice day.